Today we're asked to find the magnitude and direction of the resultant force. Given that we have three forces all acting on a point, we have 100-degree force, a 100-pound force, a 160-pound force, and a 200-pound force, all acting at a central location, pulling in different directions. We want to find the resultant force, and we want to find the magnitude and direction of that. Now what that means is we want to find one force that we could replace all three of these with. Now, the first thing I will show you is you see that you have angles of 40 degrees, 25 degrees, and 65 degrees, and two of these angles cannot be used. Because if you remember, angles must always be made with the horizontal axis for our trigonometric functions to work. So, we have to find the complement of 40 degrees for this angle, 100 pounds. Well, that's really easy. That's 50 degrees. And this 200-pound force has a 65-degree angle, but you notice it's with the y-axis. So we have to find the complement of that. And that's also real easy. It's 25 degrees. And remember, complements are just taking the angle and subtracting it from 90. Now, we have the correct angles. We just need to break these into components and combine them. So to break these vectors into components, there are two equations we need. We need to know that the x component is going to be the vector times the cosine of its angle, and the y component is going to be the vector times the sine of the angle. Okay? Now, we make a table. And we're going to break these into x and y components. And each of these is going to come out using just these two equations. So, but before I do that, I always like to go in and fill in my signs. If we look at my 100-pound vector, it is in quadrant 1. In quadrant 1, x and y are both positive. My 160-pound force is in quadrant 4. X will be positive, y will be negative. Doesn't matter what my calculator tells me. If it's in quadrant 4, y will have to be negative. My 200-pound vector is in quadrant 3. And in quadrant 3, x and y are both negative. Regardless of the answers that I get, they have to be negative, or the vector is not in quadrant 3. Now, using that information and these two equations, I want to fill in this table. And so what we're going to do is we're going to start with our 100-pound vector. The x component for the 100-pound vector would be 100 cosine of 50. So 100 cosine of 50 gives me 64.28 pounds. The y component will be 100 times the sine of 50. And 100 times sine of 50 is 76.60. Okay? Now on to 160. Its angle was 25 degrees. So this is going to be 160 times the cosine of 25. And that gives me 145.0, giving every answer to 4 significant figures. And for the y component, it's going to be 160 times the sine of 25 degrees. 160 sine of 25 gives me negative 67.62. And last but not least will be our 200 degree, and our 200 degree is going to be 200 cosine of 25. That is negative 181.3, and it'll be 200 times the sine of 25, which is negative 84.52. Okay? Now, x components are all in the same direction, so they can be added just using simple arithmetic. And I add these three numbers and I get 27.98. And I add the y components. Again, same direction, so they'll add arithmetically. And if I add those up, I get negative 75.54. So the x component is 27.98 pounds, and the y component is negative 75.54 pounds. Okay? That has found these are the components of the resultant. These are the components of the resultant. Now, how do we go from the components to what we were asked for, which is the magnitude and direction? Well, that's really simple. The magnitude of any vector is going to be the square root of the x component squared plus the y component squared. Well, in our case, we know the x and y components, so we plug those in. The x component will be 2798 squared, and the y component will be negative 75.54 squared. And if I square those, add them together, and take the square root, I get the magnitude of this vector to be 80.56 pounds. Now, we're not done. We've answered half of the question. The question said to find the magnitude and the direction. So now we have to find the direction angle. Well, if you recall, the direction angle for any vector is the inverse tangent of the y component divided by the x component. Again, these are the components of our resultant. So Fy is negative 75.54 and Fx is 27.98. So we simply take the inverse tangent of negative 75.54 over 27.98. And if you do that, you come up with an angle negative 69.68 degrees. Now, here's the problem. Again, typically, your angles are going to be given in standard notation, standard form, where you start at the x-axis and you rotate counterclockwise. Typically, your angles will be given 0 to 360. This is a negative angle. It's rotated clockwise. It's not in standard form. How do we put this quadrant 4 angle in standard form? Well, you take this angle and you say 360 minus 69.68 degrees, and you come up with 290.32 degrees. And all we're really doing is finding an angle that is coterminal with this one so that it's in standard form. Okay? 290.32 degrees. And so there's your answer. Your magnitude is basically 80.5 pounds, and it's at an angle of 290.32 degrees, which is a quadrant 4 angle. Okay? If you have any questions, please come see me.